In this video, I'll work through the sample exam for Chapter 4 for Statistics 252. Just like with the first exam, there are no calculators, notes, or books allowed on the exam. Instead, I give you a reference section, which should be pretty handy if you know what it is. Okay, here's some formulas that you can use. The first one, you should remember, is your permutations. This is the permutation of n items taken r at a time. And then the formula is n factorial over n minus r factorial. So the permutation for, say, 12 objects taken 2 at a time is 12 factorial. See how the n goes up here, remember that. And then it's 12 minus 2 factorial. Looking at the parentheses, you have 12 factorial over 10 factorial. Okay. This is combinations. The difference between permutation and combination is that in combinations the order doesn't matter. If I have ABC, then CBA and BAC are exactly the same. With permutations, ABC and CBA are two different. They're two different combinations. Well, that's a bad word. They're different. Okay. For example, if you have a committee of Billy, Susie, and Bobby, that's a combination because it doesn't matter who's first. Billy, Susie, or Bobby, Bobby, Billy, Susie. It doesn't matter. It's still that committee of those three people. Now, permutation might be a batting order where it really does count who goes first and who's second. And so you might pick those in a certain order, and you would use one batting order for some situation and another batting order for another situation. It really does count whose name you put first in that list. So that's the difference between combinations and permutations. For combinations, order doesn't make it, if you just cycle the order, it does not make it a different, it's not a different item. For permutations, it is. Okay, so here's your same thing. Combination of n items taken r at a time. The n is the total number of items. R is however many of them you're going to take. Okay. For example, here's 12 items taken 2 at a time. This is exactly the same as for the permutations. With this extra feature, you divide by r factorial because there are fewer combinations than there are permutations. So look that up and make sure you're familiar with permutations and combinations. Let me erase the screen and then let's review factorial. So factorial, 5 factorial means the factorial is the exclamation mark. It's an operation, but it's an abbreviation for an operation. It's the operation of multiplying while you're counting down. 5, 4, 3, 2, 1. So you could count down part of the way, 5 times 4 times 3 factorial, because you could abbreviate all this as a factorial, because in expansion, that's 3 times 2 times 1. And when you have these factorials, you can cancel the whole group. Before we had 12 factorial over 10 factorial. You can count down 12 times 11 times 10 factorial. And you're divided by 10 factorial. These cancel and turn into ones, of course, not zeros. And so that's 12 times 11 is the answer. The next two formulas here are probabilities of event A and event B, or event A or event B. This is your inclusive or, meaning A or B or both of them together. And A and B are here taken as events, and this is your probability. Note, this P means permutation, and this P here and here means probability. A and B are events. What's the probability that event A and event B will either occur together or one right after the other and then be in effect after that? It's the probability of A times the probability of B given A. And goes with the multiplication, or goes with addition. Seems weird because in arithmetic and goes with a plus sign. So what we have right here is the probability of B given that A has occurred. And you multiply those two probabilities together. For example, if you're going to draw, let's just draw 2 face cards from a deck. To draw the first face card, you count up how many, this would be the probability of A, would be drawing the first face card. You want to draw 2 of them. So event A is drawing 1 face card, event B is then drawing the second face card. So before you draw A, you have 52 cards in the deck, and you have 12 face cards. Jack, Queen, King. I used to put Ace as a face card, but I played cards a long time ago. Okay, so Jack, King, Queen. In 4 suits, that gives me 12 face cards. So that's the probability of A. Now, what's the probability of drawing another face card? Given that you've already drawn one, you have fewer face cards. You only have 11 left, and you only have 51 cards in the deck. Now, this is very interesting. You see how this fraction is? Leave it like this. There's no reason on a test to try to multiply 52 times 51 and 12 times 11. We could probably do that easy enough. And then to try to divide it out, leave it like this. In fact, I want to see it like this because it tells me you know what you're doing. You know that the first probability you had 52 cards in the deck. After you drew one, you only had 51. You know that you would take the number of face cards, 12, and divide by the total number of cards to get a probability, and now you have 1 fewer face card. So there's a lot to be said for that. I'd rather see that, or I want to see that, but I don't need to see it worked out. Okay, so this is the probability of A and B. Sometimes the probability of B doesn't depend on A. For example, what's the probability of drawing a face card? We know what that is, 12 over 25. And then picking up a die, and rolling it. Well, and getting a 3. That's 1/6. You see, there's no, dice do not care how many cards you're drawing. Those are they're separate and they're independent from each other. Okay, the next formula here is the probability of A or B. So it's the probability of A plus the probability of B minus any overlap between the two of them. So now I'd like you to define a few terms, and the first is mutually exclusive. 2 events are mutually exclusive if they cannot occur simultaneously. For example, I can't, on one draw an ace and a king at the same time. Right, you can draw the ace or you can draw the king, but you can't draw them both. If I'm rolling rolling a 6-sided die, I can come up with a 1 or a 6, but I can't roll both a 1 and a 6 at the same time. Those are mutually exclusive. If you have one, you don't have the other. And for mutually exclusive events, the probability of A and B occurring simultaneously is 0, because it's not possible. The second is the concept of independent. 2 events are independent if their probabilities do not depend on each other. The example here is if you pick an ace and a king from a deck of cards, they're not independent, because after you pick the ace, there are fewer cards in the deck. Right? So there's an effect on the king. I'm picking the king. Right? But now what if you pick a 10 and roll a 3? Those are independent events. If the events are independent, then the probability of B given A is just the probability of B. A doesn't matter. Or it could be written like this. The probability of A given B is just the probability of A. Now here I want you to define OR. There's 2 kinds of ORs, and on the paper, on the test, you might be asked about the exclusive OR. We generally work here with the inclusive OR. The inclusive OR means A or B can occur, or they can both occur at the same time. In this case, the probability that I own a car or a boat means either I own a car, and that's all I own, or I own a boat and no car, or I could own both of them together. That's the inclusive OR. The exclusive OR means either A or B, but not both. When I say do you own a boat or a car, it means do you own a boat and no car, or do you own a car and no boat? But if you own both of them, the answer would be no. So that's your exclusive or. It excludes the A and B. The inclusive or includes it. So why do you subtract it from that formula? You subtract it because you've actually included it twice. A complement. Okay. Complement is everything in your universal set, in all your events, that is not the one you're talking about. For example, if I talk about rolling a 3, the complement of that is to roll anything but a 3. 1, 2, 4, 5, and 6. Now in this question, you're asked to state what the following notation means in words. I've already talked a little bit about this. This is your conditional probability. It means the probability of event B given that A has occurred. If the events are independent, then the probability of B given A is just the same as the probability of B by itself, because it does not matter to B that A has or has not occurred.